Hello and welcome to another Roblox scripting tutorial. If you want to learn how to make this blood system in your Roblox games, then remember to watch till the end of the video. Anyway, before I start today's video, I'd just like to remember everybody to like and subscribe. It's completely free and it helps me out a lot. So, first things first, you have to create a new script in the server script service, and I'm just going to call this one blood system. And now we can get started. So every script I do, I create a template. This actually doesn't affect your code necessarily. However, it's just good to have because it's an amazing way of being able to navigate everything very easily. It takes away a lot of the stress of debugging and all that. So first, we'll start with services, variables, localization, connections, and then lastly, initialization. So the services we'll need for this script are the player service, and this will allow us to figure out when a player is added to the game, so we can then check for when their character is added, and everything like that. So then I will need the tween service, and the tween service is basically just a way of us being able to animate objects, properties, sort of like how animations are put on a character, but this is put on a part. Now we're going to need to define a couple variables, and this will be the fx folder. So instance.new folder, and instance.new just creates a new object of the specified class, and then we'll do local part equals instance.new part. We'll actually be using parts to create those little blood pools, and we'll be changing their shape to cylinders so it gives off that little effect. And initialization is basically stuff that has to happen before all of our events are connected for the script to work fully. So I'll just do fx.name equals parts and fx.parent equals workspace, so that all parts in this folder will actually be visible on both the server and the client. And then I'll do part.anchored equals true and part.can collide equals false, and this will just make it so that they stay on the ground and everything. Now we can actually get to the part where we design our blood parts. So we're going to do local material equals enum.material.glass, and this is just going to give off that effect of translucency that a liquid would have. And part.shape equals enum.partType.cylinder, and that will just change shape to a cylinder, of course. And now to like actual visual properties. So brick color, I'm going to change to crimson, which is like red but not super bright. It's like that dark red color I show you. And brick part dot transparency, I'll set to 0.5, just like a liquid would be. Part dot reflectancy equals 0.1, just so it reflects some of the light that is shined on it. And that should be it for designing the part. Now I will localize some of the math functions we'll be needing. I'll need the radian function, the minimum function, cosine, and sine functions. Now, many people don't actually know why people will make their functions into local variables, and that's because a global library like math, it takes longer for these functions to be executed than a localized one. That's the basic idea. I will put something about Lua U performance in the description just in case you're curious on how that really works. But now we're just going to want to know when the character is added to the game. So connect to that, and I'm just going to do player.character added connect function character, and this is so we get the humanoid and humanoid root part, and I'll do character.humanoid, character.root part equals character.humanoid root part, and I'll do humanoid.died connect function. So that's just going to check for when the player dies, of course. And now I'm going to do character size equals character get extents size. And this function is basically the traditional way of measuring the size of a model, like the character, for instance. And I'll go into why we need that in just a second. First thing we're going to need to do is create a new random generator. So I'll do local RNG equals random.new. Now this is a lot like the math.random function I know a lot of people are familiar with. However, math.random can only take integer inputs and give only integer inputs. But when you have a random.new, you could get both integers and decimals from the output. But the difference between an integer and just any old number is that an integer is a whole number. So something like 100, 5, 2, 1, 10, 3, something like that. Not like something like 3.2 or pi, which are both not, they're not whole numbers. So now I'm going to select a random amount of pools of blood, which will spill from the character. That sounded really weird. So next integer, which is basically just like math.random function, and I'm just gonna do 4. I want to have 4 7 pools, or else anything like under 4 just kind of looks strange and just unnatural. And then I'm gonna do local limit equals 1. Now I'm gonna do for I equals 0, 1, 1 divide by pools do, and this third input we're putting into our for loop is basically how much this I variable is incremented by in each loop. So that's pretty important. Now I'm just going to get a random radian, and I'm going to do rad I. But before that, we need to do local num equals RNG next number, which is different from next integer. It actually gives us decimal outputs as well. And I'll do limit 360. And I'm going to do I times num. So that's that. Now I'm going to do limit equals min limit plus num 360. And what this basically does is it will increase the minimum amount of radians that are possible, because if let's say you get the same, well, close to the same random number every time just by luck, it'll possibly spawn pools in just clusters, but only in one direction, like in front of the character, in the back, or on the sides. Whereas we want to cover basically the whole diameter of the character instead. Next, we'll also need a radius around the character. We need to define that. And that's where our character size comes in. So we'll do the standard little radius equation, which would be x over 2. And now we define some other variables. Local x equals cosine radian times radius. Local z equals sine radian times radius. Now, for anybody who hasn't done much with trigonometry in the past, I'm going to give a little bit of an explanation as to what we're doing here. Okay, so imagine a circle around the character like this. Now, we want to get a random point on this circle, which is going to be the position of our next blood pool. So what our sine and cosine functions are doing here is basically triangulating a position on this circle. So if the triangle looks a little bit like this, then it's a little bit too big. Then our point on the circle would be somewhere in this general region on the circle. And that's basically just what we're doing here. It's pretty simple, and making circles like this, I've actually used in a lot of my other code, and it's just a really useful trick to know when working in three-dimensional programming. So now with the context that we know it's a circle, I think it's appropriate to put in our y-coordinate. So I'll do local y equals negative character size dot y divided by 2. And this is basically just going to make it so our circle is right underneath the character. And I'll show why that is important in just a second. So I'll do local origin equals root part dot position, and local point on circle equals origin plus vector3.new x, y, z. Now instead of just positioning our cylinder part underneath the character, we're going to be using a raycast. Now, a raycast is basically just a function that takes in an origin and a direction and some parameters that allow you to ignore certain parts, and it creates a line from an origin and down a direction, like in this diagram, but that ROBLOX made right here. So the raycast is used to detect parts in that line and see where things would collide. It's actually commonly used in FPS games where people are making guns and swords. It's good for hit detection. Since I designed this to be as accurate as possible, I figured raycasting was just the way to go. So I'm going to do local direction equals origin minus point on circle dot unit times negative 100. Now that is a lot to take in. So what are we doing here? I'll show you. Think about it like this. So we'll say this is our origin point right here, which is the character's position. And then this is our point on the circle. Now, if we want to get the displacement between them, which is just like the straight line from point A to B, then we get this. But this might be just above the floor, or maybe the floor is right here and our circle is right here. So this raycast will never find anything, right? So we use a unit to just find basically where the vector begins, kind of, and then we multiply it by 100 or negative 100, I'm pretty sure, and that lengthens our direction so we could see more, like below, if that makes any sense. Hopefully it does. Anyway, the basic idea of that was just lengthening our field of view for the raycast. And now I will actually get into raycasting. So do local result equals raycast origin direction. But since we're raycasting from inside of the character, it's likely that the raycast is going to detect one of our arms or legs, which really isn't that good, or it's going to detect one of our pre-existing blood parts and put them on top of each other, which is also just not very good. So what we're going to do is go back up here, right under RNG, and do ray params, or maybe just params, and we'll do raycast params.new. I'm going to do params.filter descendants instances. Pretty big mouthful. Just make sure I got that right. Yeah. So I'm going to put in here character and fx. And we're going to be putting all our blood parts inside of the fx folder. And what this table basically does is it gives an ignore list. So all parts that are inside of these two objects are going to be ignored by the raycast. It's just going to go straight through. And so we specify that it is actually a blacklist. We'll go like this. Filter type equals enum dot raycast filter type dot blacklist. Pretty simple. And just input it into our Raycast function. Now, if result doesn't equal nil, which would mean that the Raycast found something, we want to execute the code below this. If it didn't, because then that would cause an error and just break our whole entire system. So what I'm going to do here is pretty simple. I'm going to be defining a height and a width for this pool. So I'm going to do 0.2 for the height, and for the width, we want to be a random width so that we're getting some differentiation in sizes. And I personally would do a 3 to 6 on that one. Just so things look nice. You don't want it to be too small, but you also don't want it to be too big as well. That's kind of the idea. So now we're going to create a new part. I'm going to do part equals part clone. And it doesn't matter that we're using the same variable twice, because we don't actually need this original part. We're going to override it. And I'm just going to do part.cframe equals cframe.new. Root part dot position. Well, no. Result dot position. Result dot position is the vector3 position where the raycast actually hit something, and putting a vector3 inside of a cframe dot new function is just going to convert that vector3 into a cframe data type, which is important here since we want to change its rotation. And I'm going to do negative rad 90, and I'll go into why I need to do that. So if I create a new cylinder part right here, you see that at its 0, 0, 0 rotational axes, it's on its side, and we don't really want to do that. So if we want to make it face upward like this, we have to rotate it a little bit, 90 degrees. And now I'm just going to do part.size equals vector3.new height width divided by 2, width divided by 2. And I'm dividing those by 2 so the tween service has a little bit of room to play its animation. And that brings us to the animation itself. And so I'm just going to make the part visible by parenting it to the FX folder. And now I create my tween. So tween service create part tween info dot new 2, and that's basically just going to specify that we want the animation to last only 2 seconds. Having it be short just looks super natural, but having it too long makes it just slow, and there's not enough time for that. So what I'm going to do is size equals vector3 dot new height width width, and that will make it so it's complete height and width, everything like that. Now I'm going to play the animation, and I'm going to connect this event. This is the completed event, and it is fired whenever the tween animation is done playing. So this will happen after 2 seconds, and I'm not just going to wait for it to wait, because that's going to yield the script, and it's going to make blood pools spawn after the character has already died and respawned. So we want this, so this code won't have to interfere with the creation of other pools. And now I'm just going to do local tween again, which overrides the other one because we don't need it anymore. And now we're going to tween its transparency so that we can destroy it eventually. And I'm going to do tween create part once again and have it last 2 seconds. And now just do transparency equals 1, so it's completely transparent. And we're going to do that completed event once again. And I'm going to connect it. And I'm not going to indent this one just because then it just looks like spaghetti code, and I don't want that. So that should be the complete script, but just in case you have any errors, it's always a good idea to exit out of the script, hit that playtest button, and just test it out and see if there's any errors, anything's going wrong, anything that we overlooked. So I'm going to reset, and as you can see, the blood pools are being created. However, it does look like they're not actually leaving, which is, of course, a little bit of a problem. So, go back and try bug fix. Now, we know, first of all, that it is actually getting to its full size, but it's not becoming transparent, and I'm not actually sure why. That's funny. Okay, so I looked back and I realized I was being kind of stupid here, and I forgot to actually play the tween animation. So we go back, make it play, and see if it works now. It really should, because it's got everything right. So there we are, and it is now gone, as you see. So if you learned something, or you found this educational, or just I just said that, but if you found it entertaining, remember to like and subscribe. It's completely free and it helps me out a lot. So thanks again for watching, and have a nice day.